The final reversible reaction that I have for ketones and aldehydes is the formation of a cyanohydrin in a reaction that looks like this. This is a reaction that takes place on a ketone like this one, or an aldehyde, in the presence of sodium cyanide, HCl, with a pH of 9. We need there to be a few protons present in this reaction, but overall a mostly basic reaction for safety. In this reaction, the product that we get out of this reaction is a cyanohydrin functional group, where I have a carbon that's bonded to an alcohol and a nitrile. This mechanism takes place under basic conditions. So that means that while there's some protons around in this reaction, there's not a lot of protons around. So I can have my ketone, like this one. In the first step of this reaction, it's going to get attacked by my nitrile or my cyanide ion, which is a good nucleophile. So it can attack at the carbon of the carbonyl, kick the electrons up to the oxygen, and give me an intermediate that looks like this. Now in this reaction, there will be a small amount of protons around in order to allow me to get my cyanohydrin product. So I can pick up a proton from the acid that is around, and that's going to then give me my cyanohydrin product. This is a reversible mechanism, so all of these arrows should be equilibrium arrows. So that when I make this cyanohydrin compound, this is stable, this is something that can be isolated, and this is something that can be carried forward through additional reactions. One of the reactions I could do is I could treat this with hydrogen gas and a platinum catalyst in order to do a hydrogenation of that nitrile, and that would give me this primary amine as the product of the reaction. This is a primary amine where I also have an alcohol 2 carbons away. I could also take this cyanohydrin and I could do a hydrolysis, H3O plus, and heat. And under the conditions of that reaction, I could get this carboxylic acid. If I want to take this cyanohydrin and I want to go back to the ketone, I'm going to run this reaction in the presence of sodium hydroxide and water in order to get that ketone back. This is a reaction that takes place under basic conditions. So in the first step of this mechanism, what will happen is my hydroxide will do a deprotonation of that alcohol, give the electrons to the oxygen, and that's going to give me an intermediate that looks like this. This tetrahedral intermediate can collapse, kick out that cyanide group, and give me my ketone product. And again, these are reversible equilibrium arrows.